Hi, I'm Mrs. Nickel, and I will be doing the Chapter 1 Vocabulary Part 2. And my joke comes later in the slides. Alright, so first of all, we have a polygon. The definition of a polygon is that it's a closed figure formed by three or more line segments. So the important part of that definition is closed, and polygons have to be made from line segments. So up here, we have a polygon. It's closed, there's no little gaps in it, and all of these edges are line segments. This one is not a polygon because it is open. This side right here is not closed, so not a polygon. And down here, this is not a polygon because it has a curved edge. It's not a line segment. This one's closed, but the edges aren't made of line segments. And another resource I wanted you to note in your vocabulary is all the names of different types of polygons are on page 30 in your textbook. There's a table off to the left, so hexagon, septagon, octagon, and also on page R10 in your planner, there's a similar resource. Next, these are two words that help us classify polygons. So polygons can be convex, and a convex polygon basically means it's all popped out. There's nothing that juts into the shape. So the formal definition, no sides, if continued, will pass through the interior, or the inside of the polygon. So what that means is if I continue all of these sides, notice that none of them go through the middle of the shape. They all just stay on the outside of the shape. So that's a convex polygon. If a polygon's not convex, it's probably concave. And concave means that at least one side, if continued, passes through the interior of the polygon. So this one, if I continue this edge of the polygon this side, right here, it goes through the middle of my shape. So that's how we know it's concave. And I also like to describe it as there's kind of a little cave inside my shape. That's how I remember concave. If there's a cave in the polygon, it's concave. So a polygon can be convex or concave. Okay, the next word is vertex. The vertex is where, we were just talking about polygons, so a vertex is where your line segments meet. That would be the vertex of a polygon. So here, okay, or it's where two rays meet. So the formal definition, the endpoint shared by two rays or two line segments. So this red dot here is a vertex, this red dot here is a vertex, this red dot here is a vertex, and at those points, two line segments meet. So those are vertices. On this angle here, I have a ray, and they share this endpoint. So this point here is a vertex. Okay, so now, an angle. This is an important geometric term, and we'll be naming these a lot throughout the year, so take your time writing this definition down. So an angle is a set of points consisting of two different rays that have the same endpoint. So over here, I drew an angle. There's the two rays. They have the same endpoint, U, and all of this space is part of the angle. This yellow is called the interior of the angle. So any point I put in here, all of these are points that are in the interior of the angle. Everything green going around this angle, forever this way, forever up here, that's the exterior of the angle. So everything in green, all these points I'm putting are on the exterior of the angle. And we can name this angle as angle, and there's our little symbol. You just kind of draw a little angle, F-U-N, so F-U-N, or angle N-U-F. could also call this one angle U. And a few things to notice, if you just use the one letter, it has to be the vertex of the angle. So U is where the two rays meet. That's where they share an endpoint. So that's the vertex of the angle, so angle U. And in these ones, when I used three letters, notice where the vertex of my angle is U. It's in the middle. It's between the F and the N, and on this one's between the N and the F, okay? So the vertex of your angle has to be the center letter when naming an angle. If we were to say angle, for example, UFN, that angle would tell me that F is my vertex because F is in the middle. So if I were to draw this, I'd put F here, and then maybe U or N, it wouldn't matter, but whatever the middle letter is, that's the vertex of your angle. Okay, do not write anything. I just want you to watch this for a minute. So I have three angles here. This is a protractor. It's how we measure angles, so we can actually measure the space between these two rays. When I'm using a protractor, you might practice this in class more. It depends on your teacher and if you already know how to do this. But there's usually a center point on your protractor. I'm going to line that up with the vertex of my angle, and I'm going to put this 0 line on one ray of my angle. So this angle right here measures 90 degrees. Okay, this angle here measures, I'm just showing you this kind of quickly. So again, center on the vertex, line this ray up on the 0 line, and if I'm measuring my angle, I'm going to go from 0 to, that's about 17 degrees. Then I'm going to come here and measure this angle, put the center on the vertex, line up this ray on the 0 line, and so I'm starting at 0, so I'm going to go these inside numbers, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, keep going, and it's about 148 degrees, so this angle is much larger. So different sized angles have different names, and this is what I want you to write down now. So we have an acute angle, which measures less than 90 degrees. An obtuse angle measures more than 90 degrees. A right angle equals 90 degrees exactly. And we usually put this little box in the corner of a right angle. If you see that box at an angle, you know that the measure of that angle is 90 degrees. And finally, we have a straight angle, which it's made of two opposite rays. So one ray is going this way, and there's a ray going in the opposite direction. So two opposite rays. This is 180 degrees. That is called a straight angle. And now here comes my joke, using these words, acute, obtuse, right, and straight. Why is the obtuse triangle always upset? Because it's never right. It cracks me up. See, here's the obtuse triangle. That's an obtuse angle. He's never right, so he's always upset. Anyways, moving on. Okay, so now more words about angles. We have an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So bisect, underline this here, bisect means to cut in half, okay? So this orange ray is the angle bisector. It's cutting this larger black angle in half into two congruent angles. So what are congruent angles, you ask? Congruent angles are two angles that have the same measure. So down here, I drew two angles that have the same measure, and I know they're the same because I copied them, and then just move this around. So angle A is congruent to angle B. A way to illustrate congruent angles in geometry, you will see these little arcs in congruent angles. So up here, I drew this one green arc and this one green arc, and that illustrated that this angle here is congruent to this angle here on either side of that ray. So that's how we know that that's an angle bisector, because it made two congruent angles. Down here, notice how I put two arcs in this angle and two arcs in that angle. That's to show you that, okay, angle A is congruent to angle B, but angle A and angle B are not congruent to these two congruent angles. So if you had a third set of congruent angles, you could put three little arc marks inside those angles. But those little arcs illustrate that the two angles are congruent, which means they have the same measure. So angle bisector cuts an angle in half, and congruent angles, two angles with the same measure. Mrs. Frasco in her video went over what this congruent symbol means. So this says angle A is congruent to angle B. Some more words with, now we're getting into special angle pairs. So we have complementary angles and supplementary angles. Complementary angles are two angles whose measures sum to 90 degrees. That means when you add their measures, they equal 90. Complementary angles can be adjacent, right next to each other, or they could be separated apart like this. So these two angles in this first figure are complementary because this box tells me, remember that box means it's a right angle, which means it equals 90 degrees. So I know that this angle in here and this angle in here have to add up to 90 degrees, so they must be complementary. These two are not next to each other, they are not adjacent, but I did put numbers in here. This one's 30 degrees, this one's 60 degrees, and if I add 30 and 60, I get 90 degrees, so this angle and this angle are complementary. Similarly, we have supplementary angles, and those are two angles whose measures sum to 180 degrees. So again, 60 degrees, 120 degrees, that sums to 180. So I could say these two angles are supplementary. And again, you could have adjacent angles, two angles that are right next to each other. So this angle and this angle would also be supplementary. Okay, some more special angle pairs. Adjacent angles, I was using that vocabulary word on the previous slide, but adjacent angles are two angles that share a common vertex and side, but do not share any interior points. So sometimes people get confused. So I drew this picture, and I wanted to say angle 1 and angle 3 are not adjacent because they don't share a side, whereas angle 1 and angle 2 are adjacent angles. So I'm going to put that here. Angle 1 and angle 2 are adjacent. They share this side, and they share this vertex. Hopefully you see another angle pair that's adjacent in that same picture. Angle 2 is adjacent to angle 3, and that's because they share this side and this vertex. So 1 and 2 are adjacent, 2 and 3 are adjacent, but 1 is not adjacent to 3. They do not share a side. A linear pair of angles are a pair of adjacent angles that are supplementary. So when you have supplementary angles that are next to each other, they do have a special name. They are a linear pair. And I like to remember that there's this word in here, line. So these two angles are together make up this whole side of a line. So they are a linear pair. They sum to 180 degrees, and they are next to each other. They are adjacent. Finally, we have vertical angles. This is our last special angle pair. This is two angles whose sides form two pairs of opposite rays. So what I mean by that are, here's my two angles, angle 1 and angle 2, and their sides, this side here in blue and this side here in blue, are opposite rays. They're going in opposite directions. And in red, this side and this side are opposite rays. They go in opposite directions. So that's how vertical angles are formed. And there's something special about vertical angles. You'll talk more about this in class, but angle 1 and angle 2 are congruent. They have the same measure, and that always happens with vertical angles. There is another set of vertical angles in here, angle 3 and angle 4. are also vertical angles in this image. So we could say angle 3 and angle 4, and finally angle 1 and angle 2. So there's two sets of vertical angle pairs in there. So lots of vocabulary with special angle pairs. Hopefully you found this to be helpful. Let your teacher know if you have any questions. And until next time, thanks. Bye.